Work it, make it, do it, make sense.
Welcome to the session on migrating to modules. My name is Mark Reinhold. I work on Java, among other things. How many people saw the session I did yesterday afternoon? Oh, excellent. That'll give you a head start. That will definitely help. So, just like yesterday, this is going to be entirely live coding. I probably will make a couple of mistakes. If you spot a mistake, feel free to shout it out. I don't mind being corrected. If you have questions of clarification, feel free to shout those out too, and I'll try to answer. But real, meaty, substantive questions, let's just leave those to the end. Okay, so what I've got here, just as yesterday, is a very fresh build of JDK 9, just a few days old. What we're going to do in this session is take a little class path application that uses some popular libraries, and we're going to modularize it. Now, those libraries themselves haven't yet been modularized. In fact, they're a little old. They're not the latest version of those libraries. So we'll see that you can modularize an application even though some of the libraries it uses have not yet been converted to modules. Then we'll do the reverse. We'll pretend that we're the maintainers of those libraries. We'll modularize those and see how our little application just sitting on its own on the class path can make use of those now modularized libraries in an effective way. And then finally at the end we'll have a beautiful module graph where everything's a module and the class path is empty, which after all is the long-term goal. All right, so I've got here a file of tweets in JSON, format of the century, not particularly readable, but hey, it's better than XML, right? So these are some tweets from my timeline from a while back. And what I've written is a tiny little app that will display these in a much more readable format. So let's take a look. We've got a main class, pretty straightforward. Package org.tweetsum. We're using the Jackson data binding API, so we import some classes from that. Our main class is pretty straightforward. Whoop. We configure a Jackson object mapper. We disable one of its properties. We read this value in from the standard input stream. Make ourselves a list of tweets. And then for each tweet in that list, we just run a little lambda to display it on the standard output stream. And this tweet class, this is the other class in this tiny little application, is basically just a little POJO. It's a data holder for a tweet. Pretty straightforward. It's using the SQL timestamp class just for amusement. Import some Jackson annotations, and then it's a pretty straightforward POJO. It's got two properties, the text, which is just a string, the body of the tweet, and a timestamp property, which has the Jackson annotations on it, and that's the time the tweet was posted. Of course, there's lots of other information in a tweet, but we're just trying to display the essential content, so we don't care about the rest, and that's fine. Okay. So let's compile. Let's just make sure this all works as a regular old class path application without anything special. I've got here in my lib directory the Jackson jar files. 266 is a bit of a stale version. I think the latest is 2.8 or something, but that's fine. So let's compile. Lib Jackson annotations, lib Jackson, lib Jackson data bind, and let's see. Oh yeah, let's do this really advanced thing here. Okay, that should compile everything. Yep. Let's make a jar. Let's see, let's stick this in lib. Whoop. There's our jar file. Okay, so I should now be able to run this. I'll just copy this class path here, add lib tweetsum and org tweetsum main tweets.json. Boom. Pretty display of some tweets. Okay, so that was pretty straightforward. We see that it works as it stands. Right, so first part, let's modularize the little tweetsum application without doing anything to the Jackson jar files. We're just we're not gonna modify them. We're just gonna use them as they exist. So in tweetsum, to make this into a module, what do we need? Exactly. So let's make one of those. As you will recall, module info goes in the root of your package hierarchy for the module. And I need to say, well, I need to give the module a name. We'll just call it tweetsum, even though that's not a very good name. I'll come back to that later. What are the essential things about a module? It requires and it exports. Let's talk about exports first. Does tweetsum need to export anything? No, it's an application. It's not providing an API for anybody else to use, so we don't need any exports. Okay, requires. What do we type for require? What do we require here? So we know that tweetsum uses those 3 Jackson jar files, so wouldn't it be nice if we could just type this or something like this? But wait a minute. These are just jar files. I mean, these are old jar files off of Central. They don't have any module infos in them, right? Meta-inf, bunch of classes, usual stuff. They're not modules. So what do? Well, it turns out we actually can type requires Jackson core. And we can do that because of this feature called automatic modules. So automatic modules are a migration tool. They let you take an existing jar file, you don't have to modify it, you just put it on the module path and the module system treats it as if it were a module. It's a bit of a special module in that it has access to many more things than a regular module does. But this is essential for migration. So if you have some existing jar files, they're fairly well formed. They don't have conflicting packages, split packages, any of that kind of messy stuff. You just put them on the module path. The module system synthesizes declarations for them at compile time and runtime. And the name of a module is taken from the name of its jar file using a pretty simple heuristic. Jackson-core-2.6.6.jar. Drop the extension, drop the version part, convert remaining punctuation to dots, remove redundant dots. It's very straightforward. It's not necessarily the best name for that module long term, but I'll discuss that more later on. So I can say here in this module declaration for tweetsum, even though those Jackson jars aren't proper modules, I can say requires Jackson's core, requires Jackson data bind, and requires Jackson annotations. Okay. Now, there's another way to figure out what tweetsum needs. How many people know about the JDEPS tool? So the JDEPS tool is a tool that we actually, it's a tool to aid migration, to aid in the analysis of existing code. It does static analysis of a jar file and can tell you lots of interesting things about its properties, both as a potential module and in terms of what other modules it might need in order to run. This tool was so important that even though we developed it for 9, we backported it to 8 update releases. So if you have a fairly recent build of JDK 8, then you have the JDEPS tool. It's not quite as modern as the one that's in 9, but it's there and you already got it. You just might not know it. So JDEPS, among other things, little side note, as many people know by now, one of the things that we've done in Java 9 is encapsulate internal APIs. So JDEPS has the ability to tell you whether you've got a jar file that's using internal APIs. Okay, good. TweetSum does not use internal APIs. If it had, then this would have printed warnings and so forth. All right. But we can also just ask it for a summary of what does TweetSum depend upon. So it needs java.base, it needs java.sql. Oh, right, I forgot. Remember I used the timestamp class? So I better put that in. Requires java.sql, because the SQL types are not in the base module. And then it said here, what's this not found stuff? Well, that not found stuff is because I didn't tell it about the class path where all the Jackson things are. So let me grab a class path and give JDEPS a class path and then ask it to do the same analysis. And see, now it determines that TweetSum is using types in those 3 Jackson jar files. All right, so I've got a modularized TweetSum. Let's compile that. Now, Java-C has gotten pretty clever about compiling modules. Compiling modules is a fairly different thing than just compiling a bunch of files for the classes directory and sticking those in a jar file. So Java-C is pretty clever now. We're going to put the output in mods. We're going to tell it the module path is the lib directory. And let me just remove that old tweetsum.jar file from the lib directory for now. Okay. We need so the module path it's kind of like the class path, but it's important in some different ways. It's where the system finds modules at compile time and at runtime. One of the essential differences from the class path is once a module is found there, classes in that module are only loaded from that module's jar file. It doesn't do the stupid naive thing of searching every jar file in the class path from front to back and taking the first class in that package that it happens to find. A big part of reliable configuration. Okay, so to compile, we also can give it a module source path. And that's just our source directory, and tell it what module we want to compile. And Java-C will go off and look at, it'll go find all those files, do timestamp comparison, figure out what needs to be compiled. And there we go. Whoops. No, this worked earlier today. Oh. Yeah. What's my error? I put the module info in the wrong directory. Okay, let's compile that again. Ta-da! Okay, so we've got an exploded form of the TweetSum module in the mods directory. We can now, we can do lots of things. Let's run Java P on that module info just to make sure it looks right. There enough. Yep, it's pretty much what I typed earlier. Good. And we can now make a jar file. We'll put this back in lib tweetsum.jar. Right. List what's in there. The jar tool has also been enhanced. It knows quite a bit about modules. We can, for example, say describe module, and it will go find the module info if there is one, and tell you about its content. Okay, so we've got the lib directory. Tweetsum.jar is a proper module. The Jackson jars are unchanged. They will be used as automatic modules. Now I should be able to run this. Give the runtime my module path. That's just the lib directory. I want to run the tweetsum module. I need to tell it what the main class is, although I could have defined that actually, but I just didn't. And let's read the tweets.json file. Whoops. No, that didn't work, did it? What happened? So what happened here is we've got an inaccessible object exception. Unable to make org.tweetsum.tweet accessible, the constructor, because module tweetsum does not open org.tweetsum to module Jackson databind. What's going on here? So Jackson databind is a small example of a framework that uses reflection. It's one of these reflective frameworks. Now, of course, a big theme of this entire effort has been providing strong encapsulation. So the module system, by default, encapsulates APIs in packages. They're not accessible at runtime. You need to export them or somehow make them available if that's what you need. So let's go back to the module info in the proper directory. What we might try is to say that this exports org.tweetsum. Right? Is this going to work? Don't know. Okay, well, let's find out. All right. I'm gonna save some time here by using a little shell script that I have that combines both the Java-C and the jar steps into one. Module path lib, module source path source. Okay. Goes off and compiles, makes a jar file, and let's run that again. What's going to happen? It still doesn't work. Why doesn't it work? Here we go, the same inaccessible object exception. The reason it doesn't work is that simply exporting a package does not make it available for the kind of deep, intrusive reflection that many of these reflective frameworks require. That is also intentional. If you're defining an API, you want to be able to say, okay, I'm exporting some interfaces and some classes for use by other modules. It's fine for them to reference them in the normal way at compile time, reference them in the normal way at runtime. But since I want to protect my internals, imagine we're talking about the java.base module where protecting the internals is essential for security and integrity. Deep reflection should not be allowed by default. So there's another keyword we can use, and that is called opens, as was suggested in this error message. So instead of typing exports here, I'll say that this module opens the tweetsum package. And what that means is this package is not available at compile time. At compile time, it's not an API, but it is available at runtime for deep reflection. I'm the owner of this code. I know I'm using a reflective framework. I don't mind if that reflective framework pokes deep into the internals of that package. That's okay. That's actually my intent. Now, it is possible, if you really need to, you can both open and export a package. The actual need for that seems to be pretty rare, but you can do that. Another thing, an alternative we could do is we could open the entire module, and that would make every package be open. And sometimes that's a way to save some typing, but it's no different than saying opens of every package that's there. So we'll just do this. We'll opens org.tweetsum. We'll recompile it. And we'll run it. And there, now we have the tweetsum application. It's a module. It's using the Jackson jar files as automatic modules, and it's all working. All right, what's next? Let's make a little JRE with the JLink tool so that we can take a closer look at what's actually going on here. Got a little make file. Here's a little JRE. Doesn't have much in it, but it has everything that we need. We know we needed SQL. We always need base. And SQL, it turns out, pulls in logging and XML just, well, because XML. Okay. So we can now rerun this with the little reduced JRE, and yeah, it works. Not only does it work, though, but there are a couple of new options on the runtime. One is show module resolution. This has changed from previous versions. We did a big cleanup recently on all the command line options. So if you show module resolution, then the runtime will print as it goes essentially a progress report of what's going on as it configures the module system. So you can see at the top it starts with the root module is tweetsum, the module that we're starting with. That's what the thing we're trying to run. tweetsum requires Jackson data bind and Java SQL and Jackson annotations. The messages show you where those modules are defined. In most cases it's in a file, but java.sql has this funny URL jrt:/java.sql. That means it's a module built into the system image using the internal JRT virtual file system. And then it builds the rest, and we're off to the races. Okay, so a word about automatic modules. They've been a bit controversial. It's been difficult to find just the right way of sort of threading our way through the various trade-offs. If what you have is an application, and it's not something where you're going to be publishing, it's not something that has an API, and you're not going to be publishing it for external use, then automatic modules are a great tool that enable you to get started modularizing your application. So if you've got an internal application, maybe it's actually composed of a bunch of modules. You can do that, or you can start with a big application that isn't, and decompose it into modules. It's perfectly fine for those modules to use existing jar files as automatic modules. What's not such a good idea is if you're the maintainer of a library, especially if it's popular. If you're the maintainer of a library that you publish to Maven Central or wherever, and you modularize it and make that library depend on other jar files using their automatic module names, that's a bit risky, because essentially when those jar files you're using as automatic modules are eventually modularized, hopefully, by their maintainers, they might choose a different name. In fact, hopefully they'll choose a sensible reverse DNS module name, which long-term is the best way to name a module, rather than the funky one that we derived from the jar file name, essentially the Maven artifact ID. So to sum up, if you're modularizing code that's internal to your organization, using automatic modules is fine. Be prepared that as those jar files are modularized, you may have to adjust your module declarations because their names could very well change. But if you're maintaining a library that is published for external use up on Central or wherever you publish it, be very wary of publishing a module that depends on automatic modules, because you're essentially putting users of your module at risk of things breaking later on, and they'll have to wait for you to update yours. Okay, so we've modularized tweetsum. Let's go the other way around. Well, that's interesting. The time left says it's still 50 minutes. Wow, flying blind here. Okay, no worries. I'm going to clean things up here. I'm going to move forward, and we're now in a different world. So here's tweetsum. I'm going to compile this the same way that I did before. It's going to be a plain old jar file, no module. Oh, time left 27 minutes. Thank you. Okay, I'm going to compile this in the normal way. And I'm going to cheat and just say lib/star. Okay, so I've got tweetsum.jar, and there's no module info in there. It's a plain old jar file. Now, let's pretend that we are the maintainers of the Jackson JSON libraries. As it happens, I have the source code for those 3 jar files that we've been using here. And they're not modules yet, but we can look inside and see, yeah, COM, faster XML, Jackson core, bunch of classes, all this other stuff, meta-in from services, whatever. So that's all there. How do we go about making a module declaration for the Jackson core artifact, the Jackson core project? Well, we can run JDEPs. That'll give us some idea. right? This will tell us about the requires, just as it told us about the requires we would need for Tweetsum itself. We can see all this information. So that helps us with the requires, but not with the exports. What do we do about that? Well, we could do something kind of crude. We could look at, say, the directory structure of that and say, okay, well, yeah, they're going to be packages corresponding to all these things. But that would be, well, kind of tedious. So JDEPS to the rescue again. JDEPS has yet another option whereby we can ask it to generate module.info.java files. JDEPS generate module info. And I'm going to type, this tool is going to write code into my source tree, always a little dangerous, so be careful that you actually want to do that. libjackson core, and now I've got a module info. Let's pop back into Emacs here. There's the module info generated by JDEPS, and well, actually that looks pretty good. It exports the packages, exports all the packages by default. There's a new thing here, and that is that there's this provides clause. So, side note, the module system knows about services. If you're familiar with Java Util Service Loader, that's been around for a long time, it's a straightforward service provider facility that's been in the platform. We've upgraded that so it's integrated with the module system. The module system understands services. And the module system needs to understand services because if you have a service provider, it might require some additional modules. And so it's all part of the whole resolution and configuration process. And so what this statement is saying is that the Jackson core module provides this JSON factory service, and it figured that out by reading the meta/services directory. Okay, end of side note. All right, let's compile the Jackson core module now that we have it. I'm going to put these new modules in a different directory called mlib. And there we go. Jar, describe, and that's exactly what we expect. So let's go on and do the Jackson annotations and data bind jar files. And what I'll do is I'll just run JDEPS on everything here. So it's going to generate 3 module infos. Now, when you use JDEPS to do this, it's always a good idea to go look at what it created because what it created might not make any sense, or it could perhaps be improved. So here's the data bind module. It's quite a large module. Let's take a look first at the exports. Are there any exports here that look like they don't belong, or maybe a bad idea to export? Util? Well, maybe, but not being an expert in the internals of this project, I'm not sure. But there are definitely these impl guys sitting around, and you kind of suspect, well, if a package is named impl, yeah, I don't want to export it. So let's not do that. Okay, so we won't export those. Oh, look, there's another service provider, and then back up the top. This is worth noting. These are requires directives, but they're a special kind of requires directive. They're called requires transitive. What does this mean? Well, it's essentially establishing a one-step transitive shortcut. So the Jackson data bind module exports all of these packages. Those packages include classes and interfaces whose signatures refer to types in the Jackson annotations module, the Jackson core module, the Java SQL module, and the Java XML module. So some other module, say Tweetsum, that's using the Jackson data bind module, it doesn't need to say that it also requires Jackson annotations core and Java SQL and XML. because that's given to it by these requires transitive directives. In an informal sense, you can think of a requires transitive as saying, not only does this module require that one, but this module re-exports the API of that one to any modules that use this module. So technically, it's not really re-exports. What it really is it's saying that the user module also requires that module. But re-export is a good informal way to think about it. Okay, so that's the data bind module. Right. Okay, so let's compile data bind, well, annotations first. And then we'll compile data bind. Oop. That's kind of a big module, it takes a little bit. And now we've got our 3 Jackson modules in the mlib directory. Okay, I already took, let me move tweetsum out of that regular lib directory and just put it here so we're sure we're not using the original versions of Jackson or anything weird like that. Okay, let's try to run this now. Java module path mlib cp classes, because that's where, well, actually it's cp tweetsum.jar, org.tweetsum main from tweets.json. Uh-oh, what happened? No class def found error. Compaster XML Jackson core blah 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 is not there. Well, what happened is the Jackson modules, they're on the module path, but they weren't loaded, they weren't resolved. The reason they weren't resolved is tweetsum.jar is just a regular old jar file. There's no module stuff going on here. There's no way for the runtime system to figure out that tweetsum actually needs those. So I actually have to tell it with another option. Add modules, Jackson core, Jackson data bind, Jackson annotations. And now it works. So we had to do a little bit of manual configuration because tweetsum is just sitting there off in the class path. As an optimization, if you remember this, since Jackson data bind requires Jackson core and Jackson annotations, we can actually get away with something shorter here. We actually only need to mention Jackson data bind. So not quite as much typing is required. So you might be wondering, how does the class path relate to modules? Well, in the module system, the way we've set things up, every class, every type is actually in a module. But there is a special module called the unnamed module. Just as we have had, basically from the beginning of time, there's been this notion of the unnamed package in Java. If you just type, foo.java and it's not in any package, you can write that, you can compile it, you can run it, great. It's technically incorrect to say it's not in any package. It actually is in a package. It's called the unnamed package. And if you read the fine print in the Java language specification or the Java VM spec, you'll see how this is all worked out. So we've done a similar trick here in the module system. Code in the class path is loaded into the unnamed module. It's a module that has no name. The unnamed module reads, in effect, it requires every other module that was already resolved. And so that's how we make sense of things. It also, of course, exports everything because, well, that's exactly what the class path does. So did I make that? Yeah, let's make that little diagnostic JRE again. And we can run it on that little JRE, and let's do the show modules as we go. And you can see here that it's doing pretty much what we expect. The add modules option on the command line specified additional routes for resolution. It configured the Jackson data bind modules, configured the rest. And then off we went. Okay, so that's modularizing the libraries without modularizing the application. Just to finish up, let's go back and make tweetsum into a proper module again. Requires Jackson data bind. Does that look right? I think that's right. Okay. Compile that. Module path, mlib, tweetsum, tweets.json. Good. And here's the diagnostic. We start with tweetsum. We see that tweetsum requires some things. And we configure Jackson data bind and the rest of it. And we're done. We have a nice simple module graph. The class path is empty. Everything is running as a module. So, to sum up, migrating to modules does take some work. It's possible to do it without waiting for all the libraries that you use to migrate to modules, and that's okay. This is in a way, this is a trick that we borrowed from generics. If you remember when generics were introduced in Java 5 way back when, we left the notion of raw types in, and we did not put in reified types, which remains a controversial decision. But the reason for that was exactly to allow you to generify your own code without waiting for all the libraries that you use to be generified. And that's worked out pretty well, although there's still a distressing amount of code out there that has not yet been generified. But there it is. So this is a trick that's come to be called migration compatibility. And automatic modules are a way to get migration compatibility as hopefully everyone moves over time towards modules. Something to say about that. It's not. I certainly don't expect every active body of code out there to migrate to modules. Migrating an existing large body of code to modules can be extremely costly and painful. I mean, it took us, 8 years to modularize the JDK. So my recommendation for an existing system is think carefully before you start down the path of modularization. You know, the OSGI folks are completely right about this. Modularizing an existing code base can be a ton of work, and frankly, it might not be worth it. But if you're starting a new project from scratch, then definitely consider using modules from the start. Okay, so further information, Jigsaw remains a fairly big project. It's covered by 6 separate JDK enhancement proposals in the OpenJDK community, plus JSR 376 for the module system itself, and that's in the Java community process. So this is part of JDK 9. It's there. It's been in there for quite a while. You can get the latest JDK 9 early access build at jdk.java.net/9. That's a new URL. The old one redirects here, but that's a new URL. We've moved it because the rest of java.net is going away. So it's there. When will this be released? I don't know. With the drama earlier this week, I think the current schedule, which has a GA date of July 27th, is probably a bit unrealistic. But I'm hopeful that we can ship within a small number of months after that. All right, we've got 12 minutes for questions. I work for Oracle. Don't believe a word I've said. Are there microphones? Is there a hand mic? Go back to the info page.
When you took Java Core and made it a module, and we compared the modular class that you created by hand and then what was put into the module itself. I thought I saw it had a requires java.base.mandated. I saw that. However, I don't remember the exact.
Oh, in the you saw the word mandated probably in the describe module output.
Yeah. Right. Requires java.base mandated.
Right. So that's a good question. Allow me to explain. The describe module option to the jar command and similar things, such as when you run Java P, they show you more than you can express in source code because there are more bits in the class file than are strictly needed to express what's in the source code. One of the bits in the class file is whether for a requires directive that was mandated by the Java language specification. So it's in some ways of more theoretical use than practical use, but it can tell a tool, for example, that this requires directive was inserted by Java C because it's mandated by the spec, rather than something that was actually expressed in the code. If I had typed requires java.base myself, that mandated wouldn't be there. So it's a subtle distinction, but it's of use to some kinds of tools. Up here in the front.
In this sample, I saw that you opened the Tweetsum module, but this is a simple case, right? So you have the Tweetsum Pollo, and it's really simple. But what happens if you have some properties in there, like I don't know, a big decimal, or a class from another module, or a class from another package, another library that is not modularized? How do you manage that?
Sorry, let me make sure I understand the question.
Because
so what if Tweetsum had been using even more complicated types from some other module?
Yeah, because Jackson now is just trying to get the properties from the tweet class,
right?
And that's easy,
right?
And you are open that to be able to access that. But what happens if you have more properties in that class that are not open?
Okay. So what if there are additional Pojo properties in the tweet class that use types that are defined in the Tweetsum module but not open?
On another module.
Or in another module
or
that's
another
not
library
open.
That is
yeah,
not
it actually doesn't matter where they are. Well, it'll depend on exactly how the Jackson data bind framework, how deeply it needs to go. It may be that it only needs to do reflection on the tweet objects themselves. Right, and if the value of one of those properties is some other type somewhere else, as long as it's exported, and Jackson can use its public API, then that'll be fine. But if Jackson for some reason has to dig in, then that other type that's being used for this value will also have to be in a package that's open for reflection. But usually in these reflective frameworks, they don't tend to follow object graphs in that way. They'll manipulate what you tell them to manipulate, and everything else they just treat as opaque types.
Thanks.
Mm-hmm.
So my question is about the early runtime failures, I guess, that we've introduced. So the runtime now catches some class of errors based on package names and modules and so on.
Yes.
Right. So if a library I use evolves its API in a breaking way by renaming a package, that will be caught early on at runtime.
If a library is evolved and it renames a package, that in general that will be fine. But if that package now conflicts with something else, then that could be a problem, and the runtime will detect it.
So I guess my real question was, if the packages are still as they used to be, but the classes get renamed, is it detected early on, or does it fail at the very last moment like it used to?
You can rename classes, it'll work fine. You might get a no class def found error later on, If you've got code code that you didn't recompile, that you didn't edit and recompile, that's referring to that. That's just the usual thing. The analysis done by the runtime, the additional analysis it does now is limited to the module graph and the package structure of each module. It does not look any more deeply than that. It doesn't go and look at types and say that, oh, well, this class is now referring to something that doesn't exist. That's detected in the same old way, no class def found error, when the code gets there. That's not detected up front.
Thank you.
Mm-hmm.
My question is about versioning of the modules. What about versioning? So if we have different versions of one module, how does it come into play? I didn't see any in the module info any mentioning about version. Is there any concept of that or not?
The number one frequently asked question. There are not versions in this module system. This has also been in some quarters a controversial design decision. There are not versions in this module system. It does not attempt to solve the multiple versions problem, whatever that means, and it has several different meanings. Because if it did, then you probably wouldn't like the result. And there are two main reasons why you probably wouldn't like the result. One is that the behavior of many existing APIs that have anything to do with class loaders, even indirectly, will change in incompatible ways. So it makes the process of moving to modules more difficult. A perhaps bigger reason you might not like the result is that all of the popular build tools have no idea what it means to solve the multiple version problem. You look at Maven, Gradle, all of these tools, they go out of their way to detect conflicts and point them out, and this is why conflict resolution can be such a pain in the butt during development, but it's something you have to do because ultimately on the class path today, two versions of the same thing are almost always a recipe for disaster. Now, long term, yeah, it would be great to solve the multiple version problem. It would be great to have some way of, module A needs version 1 of module B, and module C needs version 2 of module B, and as long as we can guarantee that the types from those two versions of B will never intersect and meet, because that would, cause an implosion, then we could support that. We have the plumbing for all of that now. It is something that we could do with not an enormous effort, but not a trivial one either in the future release. But doing it now would lead to a less than satisfactory experience because the tools don't support it, and it'll take a while. It would take a while for them to do so. It's been it's taken long enough to get the tools just to support what we've done so far. If we decided to solve the multiple version problem, we could do that, and it would take another months, year, I'm not sure how long for the tools to catch up. So what we've got is a good foundation. I think it's best to get this out now, let people start modularizing, and we'll take a deep look at the multiple version problem for future release, which, as I said yesterday, might be sooner than you think.
But what if one module, generally acquired, available module in Maven repository or something, has changed API between versions, and one dependent module is using one version, the other one is using the other version? Which one will be used? That's what I'm saying. The common problem.
Well, right now, you just have to pick one.
So I'm
what you do today to resolve conflicts in Maven or Gradle or Ivy or whatever tool you're using, you'll continue to do that.
Okay.
Right. The semantics of the module path are the module system starts at the front. It looks in each directory for a module of the name that it's looking for. It takes the first one that it's finds, and then from that point on, that's the definition of the module of that name. It never looks again.
Okay.
Okay. 2 minutes. One last question.
Imagining I'm working in a Spring or Java EE environment, and would I then usually open my application for reflection completely because it's so common, like for Hibernate, for Spring, whatever?
Yeah, so opening your whole application completely, sure, you could do that for a start. But in general, if you're using Spring, Hibernate, any of these reflective frameworks, it's best to think a little bit as you modularize, well, which of your packages are actually going to be manipulated by Spring or Hibernate or whatever, and just open those. I mean, if you want to, you can just make your whole module open, and that'll work. But as a general point of hygiene, opening just the packages that need to be opened is a better practice.
But as a library developer, I will not know if my library might be used in a reflective framework.
So that's a good question. It turns out there's a small and subtle feature that will actually enable that for reflective frameworks, even though your thing is not open, and I don't have time to explain its details right now. So,
thank you.
Yeah, I believe we have that case covered. Okay, time's up. Thank you very much. I will be hanging around the rest of the day, sometimes at the Oracle booth, sometimes in sessions. So if you have further questions, feel free to grab me. All right, thank you.